So today I want to talk about scenarios with lines that aren't parallel. So I'm going to give you a couple of equations, and we're going to graph them. We're going to see if we notice anything, and just like we did the last time, we'll get the title to our notes once we're done with this kind of exploration. So we're going to do a little graphing. So leave yourself, the title is going to be blank. We have two equations. Y equals -1/2 x plus 3, and y equals 2x minus 1. So as best as you can on your line paper, we're going to draw this graph. So that's why I have my graph paper, so I can draw the graph out. Four, 2, 3, 4, 3, 1, 2. So I labeled x-axis x on the right, y-axis y at the top, and now I put tick marks at the lines of the graph paper. I'm going to label every other point, and I remembered to put arrow caps at the end of my axes to indicate that those lines go on forever. Okay, so what form are those two equations written in? What form is y equals -1/2 x plus 3 called? Slope-intercept form. So it basically reveals those two key pieces of information, and I'm going to use just those two to graph. So what's the slope of the first line? -1/2. Remember, it's what's in front of x. What's the y-intercept? 3. Now, we shouldn't have this much of a pause, seeing that we're going to be taking a quiz next week. So we've got the y-intercept is 3. Let's look at the other equation. What is its slope? 2. And its y-intercept? Careful. What is it? -1. Okay. So in order to graph, the only thing I can graph is a point. So for the green line, I'm going to start where y equals 3. And then I'm going to follow the directions that the slope gives me in order to find a second point. So the slope number is not a point, and the slope number and the y-intercept do not make a point. The slope number is in directions to find a second point. So I have a negative rise, so that means from my y-intercept I'm going to rise down 1, and then I'm going to run to the right 2. So rise down 1 and to the right 2. So I end up at the point 2, 2, and then I'm going to draw a line through it. And again, we want to be able to use rulers so that we can see this accurately, but for our purposes, we'll be okay. The second one, the point is -1. Now, in order for me to use the slope as a directions to get someplace, it needs to have two directions. But it only has one direction because there's only one number. So how can I get that slope, bless you, to become two numbers? Yeah, put it over 1. So this tells me you're going to rise up 2 from your y-intercept, and then from there run to the right 1. So let's do that. 1, 2, 1. Now, from looking at that graph, do those lines look like anything you've seen in the past? Okay. They do intersect each other, but do they intersect each other in a special way, or are they just basic intersecting? What do they look like to you? They look perpendicular, okay? So let's talk about what that means. So what do we know is true about two lines in order to say they're perpendicular? They what? They have right angles. So you often will see like a little box in a corner. So perpendicular lines, number one, they form right angles. Okay, so let's go back to those equations and let's explore them and see if there's anything that we can glean from those equations that would tell me, yep, those lines are going to be perpendicular. They're going to meet at right angles. Chase?
The slopes are the reciprocal of the other?
Okay. They are actually more than a reciprocal. A reciprocal says, yes. Now, here's the danger with using that word. If you're going to tell me that I'm going to take any slope and take its negative reciprocal, then a lot of people think that that means I should add a negative there. But that's not what I want, right? Because if I notice here, I had one that was positive, one that was negative. So instead of using the word negative reciprocal, we're going to use opposite. Okay, good. So the slopes are opposite, I'm going to write here signs, reciprocals. Flip. So if I take negative 1/2 and I change its sign to positive and then I flip it over, I get positive 2. So those are called opposite reciprocals. Now, honestly, we used to teach this as negative reciprocals for years, but then I started noticing this trend of always having the slope being written as a negative by students. And so I thought, okay, we got to come up with a better word than negative because it makes them think that's what should be in the answer. So that's when we get to, and if you think about it, in the addition property, it talks about adding opposites. We have identity property. When I add opposites, I get 0. Okay, so they don't say when I add negatives, I get 0. Okay, that wouldn't make sense. So we need to make sure that we use that word opposites. All right, so let me show you one more thing that's a little strange. Let's take our 2 and let's multiply them. What would you get if you took slopes that we know represent the slopes of perpendicular lines, and if I multiplied them, what answer would I get? Say again? That will always happen. So we're going to add that to our notes here. The product of slopes from perpendicular lines is always, I'm yelling at you, capital letters, underlined, equal to -1. So that's a different way that if they give you 2 lines and they ask you, hey, are these perpendicular? Take the 2 slopes, multiply them. If you get -1, your answer is yes. If you get anything but -1, the answer is no. Okay, so it's a quick test when they give you 2 equations. Okay? So that allows us now to add our title. We're still from lesson 4.4. And we're going to talk about perpendicular and we're going to talk about all lines that aren't perpendicular, aren't parallel, and we call them neither lines. And today's date's the 29th of January. Last school day of January. Frightening, frightening. So I do want to share something because now we're dealing with all sorts of different signs in our slope. And when you take your quest on Tuesday, I have noticed with Math 8 and sometimes with you guys as well, is that you remember the words that Slope Dude used. And when I ask you what would Slope Dude say, you would tell me for what? For that graph. Nice negative. When you're doing math and you're coming up with the slope for this and you come up with a positive, you just carry on your merry way. So I want you guys to always keep in the back of your mind when you're being asked to graph, especially, or you're being asked to come up with a slope from a graph, that if your answer doesn't match what Slope Dude would say, then you need to fix it. Okay, so you need to keep that in mind because I have a lot of kids that will tell me, oh yeah, that's nice negative, and then give me a positive slope and then get the thing wrong. So keep that in mind about what would Slope Dude say as you're looking at graphs in particular. Because we are going to be doing a lot of graphing and sometimes 2 equations at the same time, like you've seen the parallel lines, you've seen perpendicular lines today, and we're going to do other ones later on. And if you graph incorrectly, you're not going to get the solution that you're seeking. So always keep in mind, what would Slope Dude say? Does my graph look like what the slope says it should look like? Okay, so let's give a description to what would be considered a neither line, or neither lines. Two lines that intersect, because see, all lines intersect except for parallel lines. So everything but parallel lines intersect sometime. They may not intersect on your paper because it's off your paper, okay? I've seen that happen, where it's way off the grid that you create. And so you say, oh, they never intersect. But if you see this trend of them heading towards each other, they will eventually, given enough space and room, they will intersect with each other. So lines fall into two major categories, parallel or everything else. The everything else is they intersect. So the two lines that intersect, but are not perpendicular. Oh, perpendicular. Their slopes do not match and are not opposite reciprocals. We'll do a little foldable on Monday. Okay. Oh, that's not what I meant to say. Should say their slopes. Their slopes do not match and are not opposite reciprocals. So any line where you have intersection but it's not perpendicular is called a neither line. Okay. So that leads us to the first set of directions you're going to see on homework. Okay, so first set of directions could be something like this. Now this is slightly different than what you'll see in your homework. I've made it actually harder than your homework. Determine if the lines are parallel, perpendicular, or neither. So we're going to look at the graph of y equals 5 and x equals 3. So it's a line that passes through those two values versus y equals negative 2x plus 1. So to determine whether we have parallel or perpendicular lines or neither, what we need to do is figure out slopes. So the first equation, we're going to have to figure out its slope. But I can't figure out its slope the way it's written. So to do slope, I need two ordered pairs. So first job is to rewrite these points as ordered pairs. So how would I write y equals 5 as an ordered pair? 0, 5. And how would I rewrite x equals 3 as an ordered pair? 3, 0. Okay. From there, I'm going to figure out slope. And it doesn't matter how I do it, but once I pick a direction, I need to stick with the direction both places. So I'm going to do 5 take away 0 over 0 take away 3. And that gives me 5 over negative 3 or negative 5/3. Okay. So let's go back to the second equation and let's look for its slope. What's the slope of the y equals negative 2x plus 1? So we get a slope of negative 2, and we can just write it as negative 2. So now we're going to look at negative 5/3 versus negative 2. So are they the same? So that means no parallel. Are they opposite reciprocals? No. So what that says is they're not perpendicular. So we would say they are neither. The lines are neither. Because negative 5/3 and negative 2 are neither the same nor opposite reciprocals. So you give an explanation as to why it is. Again, what your book is going to give you is 3 equations. You need to figure out the slopes of all 3 of them, and then you need to determine, do you have any that are parallel to each other, any that are perpendicular? And you could have a relationship where 2 of the lines are parallel to each other, and then a second set of 2 are perpendicular to each other. Okay? So the key is, if you find parallel, if you find perpendicular, that's all I need to hear about. I don't need to hear about what's neither. If you've got nothing, that's when you're talking about neither. Does that make sense? Yep. Okay. So let's try something else. I gave you one more shot. What if you have these 2 equations? 6x minus 2y equals negative 2, and y equals 3x minus 4. So the last time they hadn't give us an equation, so we had to remember how to figure out the equation. And actually, we just mainly needed to figure out the slope. This one, they gave us an equation. This is in what form? This is your standard form. It does not tell you the slope. So what you're going to have to do is put it into a form that reveals slope. My 2 choices are point slope or slope-intercept. Which one's the easiest one to deal with? Slope-intercept. So slope-intercept says let's get the y alone. So to do that, we start by subtracting 6x from both sides. And that gives me negative 2y equals negative 6x minus 2. Remember, it's y equals mx plus b. And then we divide everything by the negative 2. Because it says y, not negative 2y in the formula. So we get y equals 2 negatives make a positive. So I get 3x, and then over here I get a positive 1. So what we're going to do, now that we've calculated, we're going to identify slopes. So we look in front of x. This equation, we got slope equal 3. How about the other equation? What do we get for slope? Ooh, we get slope equals 3. So what is my conclusion about these 2 lines? They would be parallel because their slopes are the same. So then you would say the lines are parallel because they have the same slope. As same slope of 3. So again, when you're giving an explanation, provide evidence, and evidence is numerical often, okay? So you need to include that. Okay, so again, the homework that I see in your book is actually making you compare 3 equations. Okay, there may be a relationship between all 3 of them, or there may be just relationships between a pair of 2 of them, okay? All right, ready for the next idea of what you get to do? Remember, what we did mainly with parallel lines is come up with equations, knowing that my line was parallel to a given equation. So now we're going to do it with perpendicular. So write an equation in slope-intercept form. I'm going to clean that up. That's kind of messy. For the line that passes through the point negative 4, 6, and is perpendicular to the graph of 2x plus 3y equals 12. Okay, what's job number 1 in this equation? Yeah, we got to take the equation that our line is perpendicular to and figure out its slope so that we can figure out what our slope is. So I'm going to take that 2x plus 3y equals 12. And what's the best way to figure out slope? What do I need to do to figure out slope? Easy for you to say, yeah. Slope-intercept form. That's exactly the route we want to go. So we are going to get y alone. We start by subtracting 2x from both sides. We get 3y equals negative 2x plus 12. And then we're going to divide everything by 3. And we get y equals negative 2/3 x plus 4. So our job is to identify the slope. What's the slope of this line? I'm sorry, say it again. Negative 2/3. Just somebody's were coughing at the same time. But that's not the slope we get to use. The slope we get to use is perpendicular to this one. So we're going to make two changes to that slope. What's change one? We're going to take the sign and change it. So we're going to get the opposites. So that gives us a positive, right? And then what's the second change? Reciprocal. So we're going to flip it. So that's going to make 3 halves. Okay. So now we're going to take that slope and that point. What equation do we get to write? Say again, Rory. Point slope. I can't plug it into slope-intercept form because negative 4, 6 does not reveal the y-intercept, okay? So we're going to go point slope form. And remember, that one is y minus y sub 1, the y-coordinate, equals the slope times the quantity x minus the x-coordinate. All right. So here we go. Put those together. So y minus the 6 equals the slope of 3 halves times the quantity x minus the negative 4. So I do have a double sign here, so I am going to add the opposite, giving me y minus 6 equals 3 halves times the quantity x plus 4. All right, now what? Yep, we need to get to SI, we need to get to slope-intercept form, which remember is y equals mx plus b. So job 1 would be to distribute. We got to get rid of the parentheses. Now, you have an option here of distributing the 3 halves to each of the terms, which is what I'm going to do. And when I distribute here, remember 4 is really 4 over 1. 2 goes into itself once and into 4 twice. And then 3 times 2 is 6. What's nice is that worked out really neatly. If you're struggling with the distribution with fractions, then eliminate the fractions before you distribute by multiplying the entire equation by the denominator. Then solve it, and you'll most likely get fractions in the answer. That's okay. But if that's what your downfall is, take an alternate route. Okay. Next, we're just going to add 6 to both sides to get the y alone. And we get y equals 3 halves x plus 12. Okay. So I could not go into slope-intercept form directly because the point they gave me was not the y-intercept. All right, so that's what your homework is going to be tonight.